All right, listen, I want to show you a couple of shortcuts. This will save you some time on some of the sapling problems. It's coming in section 2.3, the rules, the shortcut rules. I want to show you on my iPad just some opportunities it'll save you time instead of having to use the whole entire rule and write the whole thing out. I want to show you that you can save time by using some of the shortcuts that are coming explicitly in just a little bit, section 2.3, etc. But if you have a function f of x squared, when you use the limit definition of derivative now, this is the limit definition of derivative. It's talked about in sections 2.1 and 2.2. All right, it's going to be presented that way. This is the limit definition of derivative, section 2.2, I believe is where it's saying. But if you have the function y f of x equals x squared, watch the outcome. The shortcut rule is going to come from this. Well, what you're going to be able to do is just bring the exponent down front and subtract 1 from the exponent. So in other words, what I'm saying with that shortcut rule is that the derivative is going to be bring the 2 down front and subtract 1. That gives me 2x. That's equal to 2x. Okay? That's a shortcut rule that's coming. Another situation to remember is that if you have the line y equals 3, for instance, that graph is a line going through y equals 3. What's the slope of that line? The slope is 0. So in other words, if you have the derivative of a constant, y equals 3, the answer to that is going to be 0. The f of x equals 3, that was not a good way to say that. If f of x equals 3, then f prime of x is equal to 0. Okay? That's saying y equals 3, boom, here, then the slope, the derivative, is equal to 0. That's that situation. Also, if you have f of x equals 7x, what's the slope of that line? What's the slope of the line y equals 7x plus 0? What's the slope of that line? It's 7, right? M equals 7. So if you have f of x equals 7x, then f prime of x is equal to the slope, which is 7. So you take this number in front, and again, that fits the rule that I just said, the shortcut. Bring the power down front and subtract 1 from the exponent. You get 7x to the 0, which is equal to 7 times 1, which is 7. Okay? So here's the situation. Let's go back up to f of x equals x squared. Look at this now. That means the derivative, if we're using this, the limit definition of derivative, then we get f of x plus h means I have to plug in x plus h everywhere there's an x, and then subtract off f of x. And it's the limit as h goes to 0 of that. This gives us the limit as h goes to 0 of x squared plus 2xh plus h squared minus x squared over h. That gives us the limit. And again, you got to keep writing this over, and that's why I said using the smiley face could be a good thing to do there. Notice what happens here. X squareds cancel off, and you end up with 2xh plus h squared over h. H is common up top. I'm going to use the shortcut this time. It's just the smiley face instead of limb. And I take an h out, and you get 2x plus h back. Remember, if you're ever doing a factorization like that, make sure you go back quickly through, multiply it back out, make sure you get what you started. This is 2xh, this is h squared, got it. Okay, and now the h is common, got it. So now I've got the limit as h goes to 0 of oh, come on now, Siri. Okay, so we've got this 2x plus h, and now there's no denominator. Early on, there's a limit as h goes to 0 has a problem because there's an h in the denominator. You can't plug in 0 there. Now the h is gone. Therefore, the h is only on top, and I can plug in 0 for h. And that gives me now that I'm going to plug in 0. I don't need the lim anymore. I get 2x plus 0, which is 2x. Notice what we started with? Power rule. Bring the 2 down front and subtract the situation. Subtract 1 from the exponent. Okay? That is the derivative. So that's the derivative. And so if I have a function that's called f of x equals x squared minus 7x plus 4, okay, what's the derivative of that? Shortcut. What's x squared? 2x. What's negative 7x? The slope, negative 7. What's the derivative of a constant? 0. So the answer here is 2x minus 7. That's a shortcut, saves you a couple minutes. That's all I'm going to say. I just want to put that on there and let you say, you can use that rule if you want to. You need to know how to use the limit definition of derivative, but the shortcut's going to save you time on some of the sapling problems, okay? All right, thank you, and keep going on the saplings, all right?